Hey, my name is Charlotte Bax. I'm the founder and CEO at Captur. Today, I'm going to be taking you through an introduction to image recognition. This is a guide not for engineers or super technical people. This is for product and business leaders. At Captur, we're a visual AI company specializing in image recognition. But what does that mean exactly? Well, it means we're in the business of understanding and interpreting images. In the next 5 minutes, my goal is to help you understand how image recognition works at a very high level. You should be armed with new questions to ask of your team and potential AI vendors. The 3 key takeaways being: 1, know what your expectations are and set them accordingly. What are the strengths and limits of image recognition? 2, define the approach. How difficult or easy will your task be for an AI to automate and solve? 3, apply it. Where can you best apply image recognition across your business? But to understand AI image recognition, let's start first with defining what an image is and how machines see them, maybe differently than humans. So an image is composed of tiny elements known as pixels or picture elements, each assigned a numeric value representing its light intensity. So levels of red, green, or blue, RGB. AI image recognition enables machines to recognize patterns in images using this numerical data, essentially replacing what we do as humans, which is our ability to perceive images, identify objects, and patterns within them. So whereas you might see the image on the left and immediately make an association to Abraham Lincoln or a man's face, this is what a machine actually sees in code. So how do we build these AI models and how does the image recognition work? How do we go from those numbers and RGB into actual learning and business impact? Well, we've all seen examples of cases where AI doesn't work, right? You put on a mask and suddenly your image, your facial recognition doesn't work, right? We go around and we try and prank the autonomous vehicles. So these are instances of where there's an AI model and we know it hasn't worked. But what goes into building the AI model in the first place and why might it go wrong? So under the hood, AI is a pretty simple process comprised of 4 main steps: data gathering, training, prediction, and testing. At the data gathering phase, what we do is we collect a data set of images. Ideally, these images are also labeled with relevant features, or what we might call metadata, to understand what might be in them, what time of day they were taken, what user took them, etc. In the training stage, like a human brain, machines need to see many different examples to accurately start recognizing patterns in a single image and across a group of images. We use supervised learning algorithms or unsupervised training methods to train networks to distinguish between different objects or different patterns in images. At the prediction stage, once trained, the AI can analyze new images and videos, comparing them to the original training data in order to make a prediction. This allows the system to assign classifications to new images that it might see. In the testing phase, we continue to test how the model performs in new scenarios and across the data that we might expect the AI to see in the real world. So 4-step process, essentially gather data, train, predict, and test. At the end of the day, image recognition is really simply pattern matching. And this is something our human brains are really, really good at. So let's try an example together. We might have a pattern here. So the numbers 4, 5, 6. And our brains can recognize each of those individually as numbers, but really they're just patterns in black and white. Now, if I show you this pattern, what might you match it to, right? Instinctually, you might see that and go, that's number 5. It doesn't look exactly like number 5, but there are enough similarities that we're recognizing some sort of pattern that ties those two together. What about if we see this image? Instinctually, you might have said, oh, that's a 4, right? We don't even need to see the full pattern to understand that those two are associated in some sort of way. And this, at a very simple level, is exactly what training those image recognition models to do. But there are definitely limits. So while AI excels in recognizing patterns using visual data, models need to be continually trained with feedback loops to better understand context in the real world. This is where you might see examples of AI getting it wrong, or getting it wrong in really funny, obvious ways. For example, maybe here the image recognition AI was trained to try and detect, is this a ping pong ball? And all of these eggs stacked in a fridge look pretty much like ping pong balls. But this isn't a photo you'd see every day. So this is kind of a new case of something unexpected, which might trip up the AI because it hasn't seen it before. So it's not sure exactly what pattern to tie that back to. Another favorite of mine is muffins or chihuahuas. So how to confuse machine learning? Well, show it some edge cases which it hasn't really taken into account, might not be in the original training data, and it might struggle in some what you think are kind of funny, obvious ways. So there are definitely limitations. A really good proxy to test how hard an AI task will be and how hard it will be to automate a task using AI is what we call the 3-second test. 3-second test is as good of a proxy as we have to say how hard it will be for the AI to learn what we as humans instinctually know. Here's a good 3-second test for you. So, is this avocado ripe? Maybe you have an immediate answer in your head. Maybe you don't. Now, the 3-second test is, does it take you under 3 seconds as a human to come up with an answer? If it does, and the faster you can come up with an answer, then the more objective the task is, and therefore the probably the easier it's going to be to train a pretty accurate AI model. If it takes you more than a couple seconds, or even would require minutes of thinking or additional context, then that's going to be a really hard task for AI to replicate at a human or above human level. And maybe you think this one's easy, but how do we know, right? Is the avocado ripe? Well, I can see some visual cues going both ways. But what's the context, right? Am I making guacamole? So is this avocado ripe enough for guacamole? Or am I making avocado toast, where I need it to be a little more on the unripe side so I get those perfect angles? What type of avocado is it? Does it naturally look a different shade of green if it's riper or more unripe based on that? What am I trying to do with the avocado? Am I trying to make a TikTok video? In which case, do I need it to be a little bit on the unripe side in order to achieve my effect? Lastly, do I have any historical trauma with avocados? Have I eaten a really ripe avocado before, which makes my personal preference a bit more towards a perfectly ripe or a little unripe avocado, right? All of this context plays into the original question of, is this avocado ripe? And if we show this photo to 5 different people, they're going to have different answers based on that context. What am I trying to do with it? What else do I know? What am I trying to use the avocado for? And do I have any other context? And so suddenly this problem, the seemingly very objective binary black and white problem, becomes more of a gradient, more of a scale, where you can think of the avocado as a range, right? You're never going to look at avocados the same way, and maybe you shift your thinking a little bit about them. But this is getting into the complexity of training AI. Seemingly simple tasks have lots of hidden complexities, and that's because of all of the rest of the context that we as humans come to images with, that machines need to learn. And the only way to learn is by seeing lots and lots of examples. It's all in the context. And there is a range. Certain AI tasks, even within AI tasks, there's a range of how objective versus subjective the decision is we need to make. You can use this when you're thinking about, well, within the task I want to automate, now how obvious, objective, how quick can someone make a decision versus how subjective is this going to be? And the more objective tasks that are very binary, is that a cat or a dog, are typically easier for AI. This might be picking out a unit number in an image. This might be distinguishing between different types of plants, for example. And there's a clear answer. There's a right answer for some things. Those are very objective tasks. A lot of those are well documented and well understood how you solve those types of problems. Then there are kind of the middle ground tasks. One that we just looked at was avocados. Is that ripe or not, right? Other potential in-between tasks include, is that damage severe or not? Is that major or minor damage for a vehicle inspection? And then you've got really subjective tasks, which are really dependent on context. They also require a very high level of expertise from humans to do the task, which means that you're probably hitting above that 3-second rule for AI. Which means these are going to require much more complex AI training, much larger data sets, and much more input from human experts. So those are the more subjective tasks. Some examples of these include medical diagnosis and autonomous driving. To put this into context, I'm sure you've seen examples of subjective or subjective images before, like this famous, what color is this dress? Two people see it two different ways. And that's a perfect example of a subjective task where what do we expect the AI to learn, right? Or you might be familiar with this type of task. Based on who we are, what context we have, we see images in a different way. This is what makes AI image recognition difficult, especially when you've got a smaller data set. Let's try another example. In this photo, do you see a house and a unit number? Well, yep, pretty clearly I see a house and a unit number, and I could probably tell you, that's number 11. If we asked the AI to detect what house number that was, there would be a right answer. It would be number 11. It's very clear cut. So that's on the objective scale. But how about some trickier cases? Is this a safe place? Well, it's a pretty creative place, but it depends on the context. How safe is this neighborhood? Is that where the person asked you to drop off the box? Have you dropped off boxes there before and it hasn't been stolen? Is this a face? Right? Are reflections faces? Are they real people? What do we do if people take photos with faces in image recognition? And a personal favorite, what is a door? This is an example from Reddit of delivery drivers dropping off next to the door. It's a pretty funny case to try and trick the AI into saying, is that a door or is it a very small fairy door? So as you can see, seemingly simple tasks, even if they're objective on the surface, might have subjective elements to them, especially when you're talking about real-world data. So that's the first question that you need to ask as a product and business owner. Of the thing we're trying to automate, how objective or subjective is the task? And where do we fall on that scale? And what is going to tip us more to the objective or subjective sides of those scales? The other thing to think about is how might the AI get confused? So whether we're talking muffins and chihuahuas or we're talking fried chicken and golden doodles, they're pretty funny cases of where AI can get confused. This is a bit less funny when we're talking about business critical operations where we need the AI to do certain tasks and we're relying on it at scale. right? So it's really important to know what cases might the AI encounter in the real world that are going to confuse it, and how can we add those into our training set and our consideration early on. That's why, in addition to the 4 main steps of the data gathering, training, prediction, and testing, in order to build image recognition system that's robust enough for the real world, there needs to be a continuous learning loop. This is a continuous feedback loop where we're always taking the learnings from deploying the model into a real world environment, taking back the learnings on what the model is doing well at, what it's struggling at, and building that back into this continuous feedback loop of model training and improving. AI software is not feature complete from day one. This is different than SaaS. What it needs is a continuous stream of data and an automated feedback loop in order to continue to learn at scale. So, where can you apply this in your business? Well, obviously, automating process with AI is going to lead to operational efficiency, right? What's really important there is thinking about how objective versus subjective the task is, to understand how complex is the AI model going to be and how much oversight you need to have over the model. Can it run by its own, or do you think you'll still need to have an expert in the loop? Improving customer experience. This is a really exciting area that things like personalization, and we've already seen a lot in chatbots, for example, can really help change your customer's experience with your product. And we're still pretty nascent here on the applications. And then enhanced decision making. This gets a lot of press right now with things like Dolly, ChatGPT. How can we just make the internal operations of a company more efficient and gather more data? Those are 3 main areas you can think about when applying AI, but remember, it all comes back to those 3 key takeaways of understanding the context, the application, and ultimately what you expect of the AI. We'd love to talk to you about your ideas for AI. Here are a couple examples of how Captur implements AI into the real world in the shared mobility and delivery sectors. Shoot us a note and tell us about your project.